All right, today we're going to start chapter 11. We're going to talk about space figures and cross sections, so three-dimensional objects. And so some definitions that you need to know. One, a polyhedron is a space figure or a three-dimensional figure. Okay, so a three-dimensional shape is called a polyhedron. All the surfaces are polygons. It says each polygon is a face. You guys know what a face is?
Yeah.
Right?
No.
Like you should. Okay, faces are on the outsides. Each polygon is a face of the polyhedron. It says that an edge is a segment that is formed between on the intersection of two faces. So it's the lines on the shape. Okay, those are going to be the edges. And a vertex is a point where the edges meet. So in this box, you can see that there's 1, 2, 3, 4, 5, 6, 7, 8 vertices. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges, it looks like. Then how many faces? 2, 4, 6, and that's it? Okay. So that's faces, edges, vertices, and polyhedrons. Okay. Now, Euler's formula, you'll want to know this because it'll make things easier on you. So Leonard Euler is a Swiss mathematician. It says right up there at the top. He discovered a relationship among the numbers of faces, vertices, and edges of any polyhedron. You think this is kind of worthless, but when you get some of these problems that have a multi-face polyhedron, it'd be nice to know this. So here's his formula. F is faces, V is vertices, and E is edges. This is the sum of the number of faces and vertices, so F plus V, is 2 more than the number of edges, E. So if you know how many faces there are in vertices, you can figure out how many edges there are. Or if you know how many vertices and edges, or edges and faces, you can find out the missing piece if you know Euler's formula. It makes it a lot easier than sitting there and trying to count them all. So I would suggest that you kind of make sure you understand this one and use it.
Wait, why?
Okay, now, a cross section. A cross section is the intersection of a solid and a plane. Okay, like they use cross sections a lot in the medical field when they cut hearts open or brains and stuff. Science box, right? So a cross section is the intersection of a solid and a plane, and you can think of a cross section as a very thin slice of the solid. So here's the deal: when you take this cross section, it's going to create a shape. Okay, and so the cross section of this here is going to be a triangle. The cross section usually looks like the two-dimensional object of the base. Okay, what's this base right here? A triangle. So the cross section, when you take a thin slice and make it two-dimensional, it's the triangle. Okay, if you took a cone, think about this. A cone has what kind of base? A circle base, right? It's a cone. So if you take a cross section, what are you going to end up with? A circle. All right. So don't make the cross section more difficult than it is. Look and see how the cross section is going in, and a lot of times it'll be the base. Now, not all the time, because it could come in diagonally and do some other crazy stuff, but a lot of the time it's going to take on the two-dimensional shape of the base. Okay, here's a question that you might see on your homework, and it says, for each polyhedron, how many vertices, edges, and faces are there? And so on some of these, you might have to count. What I want us to do is I want us to find them all by counting, and then I want us to plug them into the Euler's formula to see if it actually works. So we're going to try to find the faces, the vertices, and the edges. Okay? So first of all, how many faces are there? 6 faces. Okay, 1 on the bottom, and then 5 around. Okay? How many vertices are there? 6. Because you have a pentagon on the bottom. That's 1, 2, 3, 4, 5, and then the one at the top. So 6 vertices. And if we counted the edges,
10.
there would be 5 here, and then 1, 2, 3, 4, 5 here. So there's 10.
But I just got it 6 plus 6 minus 2.
Okay? And so if you do the formula, the formula is 6 plus 6 equals edges plus 2. So that's 12 equals edges plus 2. Subtract the 2. And you get 10 edges. Okay, so if it gets out of control, you can do it that way. All right, faces, vertices, and edges. How many faces do you have here?
6.
6 faces. Okay. How many vertices do you have? 8. Now let's just do it without counting. 8 plus 6 is
14.
minus 2 is,
12.
so we should have 12 edges. Okay, for each polyhedron, use Euler's formula, so this should be not too difficult. Okay, remember it's faces plus vertices minus 2 equals edges. I almost like the formula better that way.
Me too.
So if this is 8 here, what do these have to equal over here? Oh, wait, no, this is edges. Sorry, this is edges. Edges they put in the middle. So if we have faces and vertices, have to add to what? 14, right? Faces and vertices have to be 2 more than edges. So if they have to be 14, what does the faces have to be?
6.
That has to be 6. Now, here, we're looking for the edges. We've got 23. So what does this have to be? 21. And here we've got the edges again, so the faces and vertices have to equal 20. So if the faces are 10, then the vertices would be 10. So you can use the formula to figure it all out. I have no idea because I heard you guys say 20 and I just wrote it. So it's 10. Okay? So that shouldn't be too difficult with the Euler's formula. You have a cone and you take a cross section. What's the cross section going to be?
Circle.
It's going to be a circle.
Hexagon. Sorry.
You've got a weird shaped pyramid type thing. It's going to be a hexagon
Boom.
because the base is a hexagon. Now, this,
Parallel.
Diamond.
very good. Okay, you don't want to say that this is a square and you don't want to say it's a rectangle because the cross section is slanted, right? Your best thing to say, I don't even know if I would say parallelogram, but you could probably get away with that. But you probably want to say quadrilateral.
Wow, Caleb, I wouldn't have given it to you.
If it went straight up and down, you could say rectangle, if it's a rectangle. But when it's tilted like that on a plane,
It's unacceptable.
it's going to be a little bit different. I think a parallelogram might be okay for this one, but a quadrilateral might be a better answer for it. Okay, here's your homework assignment.
Does anybody have a pencil tomorrow?